So 12.3, the big idea is Venn diagrams. So these Venn diagrams, the circles, it's kind of a picture which at times will help you guys decipher something that's going on with probability. Mutually exclusive events. They're talking about like, can you guys take a science class and a math class at the same time? Now, depending on how you word the question, it could be math first block and science second block, right? But you can't take math and science first block. So you have to be very careful about that. So mutually exclusive, this is telling you that the two things can happen. I could have a student, math and science. So like maybe this is first block and then you go to science second block. So we can create a Venn diagram for students that are doing that. So maybe the first circle represents all the students that are taking math. The second one is all the students taking science. What does the centerpiece represent? Both, right? So this is what they're talking about. That would be a group of students, how many are in that overlapped area taking math and science first and second block. Mutually exclusive events then would be, can you take math first block and science first block? So maybe the circle then represents all the students taking math first block. So when we talk about a mutually exclusive event, can you also be taking science? So in this diagram, where are the science kids? Where are the science kids? Outside. So the circle would represent students taking the first hour math. Outside the circle is students taking, so P represents A or B. So again, let's go back to this very first situation. A is math, first hour, or I don't know, let's just say math during the day. And B is science during the day. So you guys, some of your friends took science first semester, some of you friends took science now, you guys are taking math now, some of them took math earlier than you. So how many students took math or science at Hopkins High School? So what is A or B represented by in the Venn diagram? There are some students that took both this year, right? Some students only took math this year. Some students only took science this year. But collectively, it's everything inside the circles. What we have to be careful for is this group. Do not count twice. Do not count that group twice. So if there are 400 kids that took science and there are 500 kids that took math, maybe there's 100 kids in the middle. We can't count them twice, so you have to be very careful how you add that up. And complements we've already talked about. It's just everything else. So if you're in the group, if you took science, then the stuff on the outside is I did not take science. All right? A candidate is running for mayor of his city. The results of a survey done by his campaign are presented in the Venn diagram below. The circle of A represents people who are planning to vote for the candidate. So if this is your campaign and you're calling people up and saying, who's the candidate you plan to vote for, these are people that are on your side. And then B is simply that when I called or we talked to somebody, we took a survey, that the person was a woman. So A are people who are saying yes to our candidate. B is simply a woman that's in the survey. So are events A and B mutually exclusive? How can you tell? Is it possible to be, basically they're asking you, is there going to be an overlap of the two events?
Yes.
Will there be an overlap? Is it possible to be a woman and be yes for that candidate?
Yep.
Yeah, okay. What's that?
So are they mutually
I really don't care. I don't like language memorizing mutually exclusive. Just say yes, there can be some sort of overlap, right? The two circles are not independent of each other. There will be some overlap. What does the 41 in the diagram mean? A yes and a woman. So when we called up these people or we sat on the sidewalk and just bothered them as they walked by, they were saying yes, I'm for your candidate, and then you identify them in the survey as a woman. How many people in the poll intend to vote for our candidate? How many people in this poll intend to vote for our candidate?
193.
152 and the 41. It's everybody inside the circle. So 152 plus the 41, and we end up with 193 total yes votes. How many people were surveyed?
354.
Well, there are 152 yeses, 41 women that said yes, another 91 women that said no, and then 80 more people that, what does this 80 represent? Does that ask us eventually? Whatever. So when you add those numbers up, what do you get? 364? Is that what you're saying? 364. So basically you're adding up all those numbers. Find P of B. What this is saying is find the probability of event B. So, what is the probability that when I was doing the survey, I was surveying a woman? So we have to add up all the women in the survey. 41 were saying yes to our candidate. Another 91 said no, so add those two numbers together. 41 plus 91, and then what are we dividing by? Because remember, probability, I either want the reduced fraction or the decimal. The total number of people. So what is 41 plus 91? Hit enter, that's 132, and then divide by 364, what do you get? 0.36?
Yeah.
0.36. Find the probability of A and B. So what's the probability that the person in the survey said yes and they were a woman? That's the overlapped part. Yes, so 41 divided by 364. What's the decimal? 0.112. So about 11% chance. Okay, find the probability of A and not B. So remember, what's A? People that said yes, right? Yes, I'm voting for your candidate. There That's the 192 number, or what, excuse me, 193. Inside circle A. And then they say not B. So it's the group that said yes, but not the woman. So it's got to be outside circle B. So inside circle A and outside circle B, that's this group right here, right? So the probability is 152 divided by 364. What?
Like 417.
0.417. So about 42%. And finally, what's the probability that the person said yes or they are a woman? So that's everything inside the circles, correct?
Oh.
Would not work.
Would not be the overlap?
Or, so I would ask, you know, in my survey, I would take all the women in the survey, and anybody that said yes, those go in a group. And this is where in the Venn diagram, how many women are there in our survey? How many women in the survey? What do we have? 132. How many people said yes to our candidate? What? How many people said yes?
193.
193. So this is where I talk about, I don't add these two numbers together, right? Because if I add 132 plus 193, what am I doing?
You're adding.
I'm adding the overlap group twice. So basically what happens with the Venn diagram is it's a lot easier to see. I just want those three numbers. So what's 152 plus 91 plus 41?
284.
So that's 284 divided by 364, and what do you get?
0.78.
0.78. A governor recently approved funding for a sports stadium. Several weeks later, a poll asked a group of registered voters following questions. Do you agree with the governor's position on funding the sports stadium? Will you vote to re-elect the governor in November? S represents the entire group. So notice where S is. S is the box that's going around our Venn diagram. A, those are the people that answered yes to the stadium question. So that's circle A or oval A. And B, those who answered yes to the re-elect question. Describe the voters' responses that are represented by the shaded part of each Venn diagram. So I'm going to pause the video. With people near you, you're just going to talk about what those two shaded areas represent according to the Venn diagram. So it's yes to the stadium question and yes to re-election. So maybe write, it's easy to say yes stadium, yes re-elect, no stadium, no re-elect, that kind of stuff. So write that down, I'll pause it, and then I'll ask for some help. So on this first question, it was outside of circle A, so they're saying no to the stadium, but they're still inside circle B, so they're saying yes to the re-elect. In the second graph, the Venn diagram, they're outside both of the circles, so they're saying no, we don't agree with the stadium vote, and no, I will not elect or vote to elect a current candidate. Now, the survey reveals that 60% answered yes to the stadium question. 48% said they'd vote for this re-election, vote for the candidate for the re-election, and 38% answered yes to both of the questions. Fill in the Venn diagram. Let's start in the middle they're telling me that 38% said yes to both questions, right? So that 0.38 is gonna go in the overlapped area because that's where the yes is to both questions. We have to be a little bit more careful when we fill in the other parts because can I put 60 here? No. The idea is 60% is in the circle. So if I've already got 38% inside the circle, how much is left for the outside?
22%.
Only 22%. Those two numbers have to add up to the 60% that answered yes. Because of the people that said yes, some also said yes to re-election and some said no to re-election. So then, when you look at the 48% has to add up to the circle B. So that must be a 0.1 on the outside there, right? So do my two numbers inside A add up to 60? Yes. Do my two numbers in circle B add up to the 0.48?
Yes.
Yes. What is on the outside then? How many said no to both? So in the Venn diagram, you can just add up those three numbers and now subtract from 1.
Add up all of them.
Add up all those numbers and subtract from 1. What do you get? 0.3. So the idea is, given the numbers like this in the problem, you can't add these up because it adds up to more than 100%. Down here. So, what percent of those asked answered yes to the stadium question only? Yes to the stadium question only. That's this outside group. 0.22. Where did that go? You have to be inside circle A, but not in the overlapped portion. What percent of those asked answered no to at least one of the questions? No to at least one of the questions. So looking at the diagram, what are we going to look for? No to at least one.
Everything but the double overlap.
Everything but the overlap portion, right?
Yeah.
Because you could have said no to both. You could have said no to both. That's this group. You could have said yes to question 1, but no to question 2. That's that group.
I really wasn't on it though.
I don't. Or that group. So you add up those three numbers. And what do you get? 62%.
Everything outside of
Everything outside of the overlap. Because if you make a tree diagram, sometimes some of you, it'll help to make a tree diagram. Yes, no, that counts. Yes, yes is the only one that doesn't count, right? So that's the overlap. Given a person answered yes to the stadium question, what is the probability that the person answered yes to the re-election question? Now, the weird thing is, you look in the diagram. In our diagram, who answered yes to the stadium question? That's this group. So what percentage answered yes to the stadium question? 60% did, right? Or 0.6. Of that 0.6, how many answered yes to the re-elect question? 0.38, the overlapped area, right? So you want to take what's 0.38 divided by 0.6? That'd be like saying, you know, if there are 100 people, here, there'd be 38 people out of the 60 people. So what do you get when you do this?
Point six.
Point what?
Six.
0.63 repeating?
Yep.
Sure. And then finally, given a person answered no to the stadium question, what is the probability that the person answered no to the re-election? So what's the percentage of people that said no to the stadium question? How many people said no to the stadium question?
Yeah.
No to the stadium. These two numbers are yes to the stadium, right?
No, you're thinking of.
Oh, stadium, sorry. The 0.22 and the 0.38 are the stadium question. So how many said no to the stadium question? 0.4. So I'm gonna write that down. That's the no to the stadium question. Of those people, what is the probability that they answered no to the re-election question? So of those two numbers, 40% of our survey said no to the stadium. So what's the probability that they said no to the re-elect? So you're given this group. And again, if I had 100 people in the survey, this would be representing 40 people. So given those 40 people, I bring them into the room. What's the probability that they are also going to say no to the re-elect? So how many said no to the re-elect? 0.3. So I can take 0.3 and I can divide by 0.4. Think of it as 40 people in the room. 30 out of the 40 say no. So what do you get? 0.75. This is a given probability. It's kind of like when we had that table the other day. Who do you bring into the room for the survey? I'm bringing in the 40% that already said no. Now, what percentage of those people? So it's the division, the part divided by the whole.